Hello everyone. Today I am going to solve problem 3 of homework 3. So let's go through the question. What the question says. So question says the heat capacity for a liquid is given as a function of T, which is Cp. T is A plus Bt, where A is given 100 and B is given 0.1067. So you have to compute delta H at a TA 170 to TB 270, also delta S for this process as well. So before deep diving into the equations, so let's solve like what is the relation between H or delta H and Cp. So we know that H equal to U plus PV, where U is internal energy, P pressure and volume. So I'll just write it as like differential from, so dH will be du plus pdv plus bdp based this is based on chain rule. Now dH will be d q plus w, this is the first law of thermodynamics, plus pdv plus vdp. So I can rewrite it, dH will be dq plus dw pdv vdp. So let's say I can rewrite dq, so dw is our always minus of pdv plus pdv plus vdp. So these two will cancel out. Also this tends to 0 since in a quasi-static process dp is always 0. We assume dp is always 0, so this also tends to 0. So that means our dH is always equal to dq. But this didn't solve our relation between H and Cp. So how to get H and Cp relation? So to do that, we know that Cp is always equal to dq upon dt at a constant pressure, because we are calculating heat capacity at constant pressure, so our pressure will be constant here. So dq upon dt at a constant pressure, we know that dq is always dH, so we just substituted it, dH upon dt at constant pressure. Also H equal to T del S, so we can easily substitute dH equal to T del S, so T del S upon dt at constant pressure. So if I now remove this partial derivative to integral form, I will get my delta H is always equal to Cp as a function of T integration of dt from T2 to T1, or delta S equal to 1 upon T Cp dt integration from T2 to T1. So now we got the relation between Cp and delta S. That's the part we were looking for. Now we can solve our question. So our question says Cp is given. So Cp is given as a function of time, and we just have to integrate it. So delta H is always Cp dt integration, so that will be A plus Bt dt, that will be At plus Bt square upon 2 from T2 to T1. Also T2 T1 is our given, it should be T1 to T2. I wrote it wrong. So T1 to T2, our T1 is given here, it is 170k, T2 270k. So now we can solve it. So 100 to 70, 170, this whole thing will now come of 1.2347 into 10 to the power 4 joule Kelvin inverse mole inverse. So this is our value of delta H. Now to solve delta S, same, one more integration from T1 to T2 Cp upon T dt. So that is A plus B T upon T dt, which will now give us A ln T plus of B T. So now we can substitute the value 100 ln, because T1 T2 are given here. We can substitute the value, which I will get delta S equal to 56.97 joule Kelvin inverse mole inverse. So I got my delta H and my delta S, which is asked in the question. Thank you. Let me know if you have any questions.